Part 4, you will hear a university lecture on machine-readable codes and their role in retail and logistics. First, you have some time to look at questions 31 to 40. Now listen carefully and answer questions 31 to 40.
Good morning. Today we are looking at machine-readable codes and their effect on retail and logistics. I will cover 4 points: the supermarket problem that led to early barcode research, the commercial introduction of the Universal Product Code, the way linear codes are read, and the later development of two-dimensional codes and RFID systems. The original demand came from supermarkets. Managers wanted to reduce checkout queues, but they also wanted easier stock-taking. Counting items by hand took time and produced unreliable records. The aim was not simply to make the cashier faster. It was to connect each sale to information about stock. That connection is what made the idea important for management, not just for the checkout counter. The earliest important design was developed by Norman Joseph Woodland and Bernard Silver. Their patent was filed in 1949 and granted in 1952. The idea was ahead of the equipment available at the time. Their original concept showed how printed marks might encode information, but the reading device had to be reliable in a noisy commercial environment. A working commercial system needed a printed symbol, a scanner, and a computer able to connect the symbol to product data. The missing technology was not just a better lamp. Practical scanning depended on a bright laser and a computer. A laser could produce a narrow beam of light that made it possible to read the contrast between dark and light parts of the symbol. The commercial breakthrough came in 1974. At a Marsh supermarket in Ohio, the first product scanned with a Universal Product Code was a pack of gum. It was chosen partly because small packaging showed whether the printed symbol could work on a difficult surface. The event was modest, but it demonstrated that a symbol printed on an everyday product could trigger an automatic transaction. Let us now consider how the code works. A linear barcode represents information through a pattern of dark bars and light spaces. The scanner does not read the name of the product directly, and it does not understand the visual pattern in the way a person reads a word. It detects variations in reflected light as the beam moves across the pattern. Most retail codes also include a check digit. This is a final number calculated from the other digits in the code. If the scanner reads one of the digits incorrectly, the calculation will not match, and the system can reject the reading. A key point is that the barcode is not the whole database. The scanner links the printed symbol to a product database, where the price, description, and stock information are stored. This is why a shop can change a price in its computer system without printing a new symbol on every item. The wider effect was on inventory. Because every scan created a record, retail records became more accurate. Managers could see which products were selling, which shelves needed restocking, and which deliveries had actually arrived. This made planning less dependent on estimates or occasional manual checks. Later systems expanded the principle. Two-dimensional codes are made from small square modules rather than simple vertical lines, so they can carry more information in a compact area. They are now used for tickets, product tracking, and mobile links. The same principle remains. A visible symbol allows a machine to capture data quickly and consistently. RFID takes a different approach. Instead of printed bars, RFID identifies objects by using radio waves between a reader and a tag. This can be useful when items are inside boxes or moving through a warehouse. To summarize, machine-readable codes began as a response to supermarket checkout and stock problems, but they became a foundation for modern logistics. Their importance lies in automatic data capture. Objects can be identified quickly, records can be updated immediately, and supply chains become easier to monitor.
That is the end of Part 4. You now have some time to check your answers.